Hello, everyone. Thanks for staying this late. Today, I will talk about how Pinterest tracks the state of builds. This is part of the journey of Pinterest through our build program. My name is Manuel Nakamura Kare, and I am an engineering manager at Pinterest. Before I get started, I want to talk a little bit about Pinterest. Our mission is to bring everyone the inspiration to create the life that they love. We also like to think ourselves as the last positive corner of the internet. We have 460 million global monthly active users, and we are hiring. We still have a very flexible remote policy, so in case you are interested, please check out the website and let me know. All right, let's get started. Before I go too deep into the topic, I want to give an idea about the scale of mobile at Pinterest. This is for both Android and iOS. So we have a few million lines of code, a few hundred contributors, tens of thousands of builds per month, and thousands of commits per month. So I have this question: why should you care about builds? Well, there are many reasons why. One that was mentioned before, right? This is the year of efficiency. We want to do more with spending less. By having faster builds, that's one way to do it, right? Like faster builds means a faster developer feedback loop, so developers are able to produce more. But there's also the other side that was also mentioned before, which is less context switching, less cognitive fatigue, and more happy developers. Why is it important to have a build score? Well, there are a few reasons. One is that it allows us to measure the developer build experience without having a number. It's very hard to know unless you ask them actively, right? How is your real experience? So by having this single number, we are able to get a better sense of how the developer experience is and if they are having any maybe blockers or anything is going wrong. There's also another reason. Before we had this build score, we used to provide many numbers to upper management. We used to provide local P50, local builds P95, the same for CI, test flakiness, etc. Right? As you can see, it can get very complicated, especially if you are an upper manager and you don't have a lot of this visibility. You can get confused very, very quickly. So that's why we also decided to come with a single number so that they can quickly understand what's happening and plan accordingly. Then there is also another benefit. It allows, again, upper management to have better visibility on potential hotspots in the developer workflow, right? The developer workflow has different parts. There is maybe you are having PR reviews that are taking a long time. Perhaps your deployments are taking a long time. So by also having visibility into the state of builds, they would know if they have to prioritize investments in this area or not. What are some ways to measure the state of builds? So I'll talk very quickly about a couple. The first one is Dora, also mentioned in previous talks. Dora focuses a lot in these metrics like deployment frequency, change failure rate, time to restore. Then there's also the Space framework, which, similar to Dora, also measures performance metrics, but also other things like well-being, communication, and collaboration. The challenge that we had with those metrics is that they don't measure the set of builds directly, but indirectly. So in case your organization is planning bigger investments in builds and they really want to know how builds are performing, then it's probably better to look for more to metrics that provide stronger signal about builds. So in this case, we came up with this number. We are using these metrics that allow to measure the dev experience, which are local and CI speeds, plus also the success rate for both. And this is an example of how it looks like. It's pretty simple already. Instead of having 10 or 12 metrics, we just provide this: Android 85%, B, iOS 70%, or C. In the next slide, I'm explaining what these letters mean. This is based on the American grade system. So A, 90% to 100, that means that the set of builds is good. Then we have D, for example, 60 to 69. probably lots of issues with the build, and F less than 59%, it's in an acceptable state. In our case, we will likely declare a code yellow, which basically means the team needs to drop everything that they are doing in the sprint and prioritize the work in order to get the build in a better state. How is it calculated? So you already spoke about the two dimensions that we take into account, local builds and CI builds. So I'll just look at this in more detail. So as I said, local builds and CI build time, we use those metrics. In the case of both, we have P50s, P95s, but we wanted to come up with a number that goes from 0 to 100, and we also wanted to focus on the worst cases. So in this case, we decided to go and just measure the number of builds that go below a threshold. In the case of local builds, our threshold is 10 minutes, and in the case of CI builds, our threshold is 4 minutes. But these numbers are arbitrary, so it depends on your situation. You can choose different thresholds. And in the case of pipelines, this is relevant for CI. So in the case of CI, developers care about the pre-commit experience. The pre-commit experience is basically any builds that happen before the developer has merged or landed their PR into the main branch. And they don't really care too much about the time that it takes to check if the master branch is green. Then we have CI uptime. So in the case of CI uptime, again, we have some options for pipeline, right? We have the pre-commit pipeline or the post-commit pipeline. In this case, it's more relevant to choose the post-commit pipeline, since the post-commit pipeline is supposed to be green. The pre-commit pipeline sometimes is going to be failing, sometimes not, depending on the changes that a developer has done in their PR. So in this case, the post-commit pipeline is supposed to always be green. And if in case it's not, then that means that there's probably some system failure, maybe some flaky test got into the main branch, things like that. And those are things that can affect the CI success rate. And then just quickly coming up with a formula. So based on everything that I talked about, we take the local build times below threshold, the CI build times below a threshold, and the uptime. And that's how we come up with a number. We also give some weights. In our case, we prioritize CI uptime versus the speeds. So we give more weights to the CI uptime. But yeah, again, it depends on the case. And some tips that I wanted to provide if you are maybe thinking about working on score, I would advise people to try to use the existing metrics, or metrics that are very easy to come up with. And the reason why is that coming with metrics doesn't really solve the problem, right? It allows you to measure the problem. So even though it's important to be able to measure it, it's also important to try to use whatever is existing so that you don't have to spend too many resources on something that doesn't really fix the problem. The second tip is to iterate. In our case, when we started measuring this build score, we, instead of using the pre-commit pipeline to measure the build time, we were using the post-commit pipeline. Later on, we realized that developers would care more about the pre-commit experience, right? Since that's what they have to wait on before they are able to land or merge their PR into the main branch. So that's why we decided to iterate and change. And third one is remember your objective. In our case, the objective is to be able to measure the developer build experience. So we don't really try to go too much around it, because our objective is just to get a sense of what's the state of the builds. And lastly, I want to go through some examples of the build scoring action. So here in this graph, you can see two lines. One is for iOS and the other one is for Android. So in the case of iOS, you can see in November, we had a big drop down there. In this case, yeah, you can see the build score. And what happened was that we were having a lot of out-of-memory issues. So that's why the build score suffered at that time. Later on, we were able to fix it by using the Gradle configuration avoidance API. And in that way, avoid running too many unnecessary configuration tasks that were causing unnecessary memory usage. Then in March this year, again, we had a drop in the score. As you can see there, this time what happened was that we had detected that some clusters were not using the full capacity of the CPU. So we decided to downgrade our machines, right? It's the year of efficiency, so we're trying to cut costs. But then we didn't realize that it would come with a consequence, and the consequence was that the speeds of CI suffer a little bit. So later on, we decided to basically have two clusters, one with a high CPU capacity and another one with the original CPU capacity. So that way, steps in CI that needed more speed, they use the more expensive cluster, while the other one uses a cheaper cluster. That way, we were able to optimize in cost while keeping the build experience the same. The last example is, the last one is for iOS. So as you can see, iOS has been in a downward trend. We've had multiple transient issues, and more lately, we are facing a lot of lack of erase issues, where we know that we have to probably start thinking about using a merge queue. So that's something that we are thinking about doing next. And that's all. Thank you very much. So now I think there is some time for Q&A. So in case anybody has any questions, please go ahead.